Yo, yo. I think today I'd actually like to kind of go over matrix multiplication. And it's a little interesting thing, and it actually comes up a lot later on, especially if you go into the hardcore sciences or engineering a lot, especially, it's used a lot in computer science, electrical engineering, physics, pretty much everything. So what a matrix is, it's essentially it's a large collection of numbers, right? You're going to think of the movie, The Matrix, right? And really, what is it's just a large collection of numbers that you can do a bunch of operations to, and you'll get some different outcomes for it. So let's just say in this case, I had, and they're mainly used with systems of equations, linear equations in this case. So if you have, let's just say you have a equation like, y is equal to, 2x plus 4. Uh, you have g is equal to, let's just say 4x minus 7. This is a system of linear equations, right? It's linear because your x power is to the 1, right? And you can write this in a different form, and that form would be ax is equal to b. So what you're really going to be doing here is you're going to be taking, let's make b is going to be equal to a matrix. It's going to be a 2 by 1, which is going to be y and g. You're going to have a, which is just a numbers matrix. It's going to be a 2 by 2, 2 rows, 2 columns. It's going to have 2, 4, 4, and -7. Right. Let's actually make this more interesting. Let's actually write down, let's write z here. All right, 7z looks a little weird, but anyways. Right. And then you're going to have your x matrix. X is just it's a matrix that's holding your variables inside, right? Again, it's going to be another 2 by 1. You're going to have x, and you're going to have z, right? So like I said, these are just collections of numbers or variables in this case, either one. And so I should be able to multiply these things out and come out with this thing, right? So let's try it out. Let's try maybe a different color. Let's go maybe magenta, right? So how this should work is I have 2, 4, 4, -7, and then I'm going to multiply that. Then I'm going to multiply that by x and then z, and I should get whatever is inside of here, right? So how this is going to go is for the first matrix, you're actually going to start counting across, and then for your second matrix, you're actually going to start counting down. So 2 is going to go with the x, right? So I'm going to get 2x. Then I'm going to go over 1 and then down 1. So 4 times z can be plus 4z. Right? We reached the end of this row, we reached the end of this column. So we're going to do it again. We're going to go over here. We're going to go down again, right? So it's going to be, this 4 is going to be multiplied by the x, right? 4x, then -7z, -7z. So you see we got whatever was inside there. And this is obviously equal to b, right? Equal to your matrix or vector b. It's going to be a y and a g, and you can kind of already see that this y is going to go to this equation, and this g is going to go to this equation. So pretty simple, pretty straightforward matrix multiplication. It'll help you out a whole lot. There is one special rule, and that is if you have, let's go to a new page. If you have a matrix A and if you have a matrix B, you are only allowed to multiply them, and typically there's dimensions that go along with it, right? So let's just say you have a matrix A. This is A, and we're going to multiply it with matrix B, right? It could be a big one, could be a small one, could be whatever. These have dimensions. Typically, they're n by m dimensions. N stands for the number of rows. Rows are how far down you go. I have 1, 2, 3, 4, 5, 6 rows. M stands for columns. columns? How many, how many pillars do you have? 1, 2, 3, 4, 5, how many ever, right? So in this case, let's just say you have an n by m matrix. The only constraint is that in order to multiply these two matrices together, the number of rows in your second matrix needs to be the number of columns in your previous one. So in this case, it needs to be m, and I can multiply it by any other number you want at this point. It could be k, it could be j, it could be n, it could be m, right? It could be whatever you want. As long as these two are good, they cancel out. Also, you'll be left with the brand new matrix. Let's call it C, right? And the number of rows and columns in this case would be an m by k matrix. Right? Pretty simple, pretty straightforward. Try it out for yourself. Let's maybe do one quick one. So let's just say I have a matrix A, right? Let's just do 1, 2, 3, 4. And I got matrix B is equal to 0, 20, 1, and -3, right? I'm just making these numbers up. As you see, they're both 2 by 2 matrices, right? So I'll do 2 by 2, 2 by 2 here. So in that case, I should be getting a matrix C. And what would the dimensions of that be? Well, this is going to cancel out with this, and I'm going to get 2 by 2. So clearly, this is a 2 by 2 matrix, right? Not that bad. So let's put that there for us to hold, and let's actually go forward with this. Okay, so let's try it out, man. All right, so the one, you're going to go across on your A matrix, and you can go down on your B matrix, right? So you're going to have, oops, let me do that. Cool. So let's just call this out. Your brand new matrix, this will be brand new matrix C. So you're going to have 1 times 0 is 0 plus 2 times 1, which is 2. Okay. You're going to go across again, right? 1 times 20 is 20. You're going to go across until you reach all the elements in your B matrix. 2 times -3, -6. Okay. You can kind of see this 2 columns already filling out, which is going out great here. Now we're going to go down. We're going to go across and down again. 3 times 0 is 0. 4 times 1, 4. 3 times 20 is 60. 4 times -3 is -12, right? Cool. See, we have a 2 by 2 matrix here. That's filling out perfectly. So 20 minus 6 is 14, right? 0 plus 4 is 4. 60 minus 12, I'm not that great at math, even though, right? So 60 minus 10 is just 50. It's going to be 48. 48, cool. So this is going to be equal to C, right? Good stuff. I'll leave that there. It's going to be equal to C. The other thing you can do with a matrix is you can actually pull out numbers from it if those numbers are within all those same elements. So in this case, see if we can do that here. So what number or numbers are all similar in every single element here? If you notice, everything can be divisible by 2. So I can rewrite this as, let's just say, C is equal to 2 times, and that's going to be a 1, that's going to be a 7, that's going to be a 2, and that's going to be a 24, right? So you can multiply numbers or scalars into a matrix, but you have to multiply it by every single element in it, right? So these two things are equivalent. So pure, quick, and simple matrix multiplication.